Hi guys, I'm here to teach you on how to solve definite integrals. But first, one must first know the basic concepts of limits, summations, and after knowing these things, now let's start to solve definite integrals. The formula of definite integral is defined as the integral of a to b f of x dx is equals to the limit as x approaches to infinity, the summation of 1 to n f of x sub I star delta x. Now, let's work on a quick example. Let's solve the integral of x squared plus 1 from 0 to 2 dx. In order to get the width of each subinterval, we're gonna use the formula where b minus a over n, or also equals to 2 minus 0 over n, or equals to 2n. That means that each subinterval have a width of 2n. The subintervals are then 0 to n, 2 I minus 1 over n, 2i over n. As we can see, the right endpoint of the ith subinterval is this. It is equivalent to the 2i over n. Now let's work on the summation part. And let's substitute the values that we get from earlier. The summation of 1 to n is equals to the f of 2i over n to n. Now let's substitute this to the function x squared plus 1. And this is the function that we will get. The summation of 1 to n 2i over n squared plus 1 multiplied by 2n. All we have to do is to distribute this 2 over n. Let's distribute this summation to the two terms. We're gonna get the summation of 1 to n 8i squared over n cubed plus the summation of 1 to n 2 over n. Will be the result when we put out the constant. All we have to do is to evaluate these summations. As we recall in the special series, this can also be equivalent to this, and this will also be equivalent to this. All we have to do is simplify those two terms, and it will become this. Then all we have to do is combine it, and it will become this. We can now compute the definite integral. The integral of x squared plus 1 from 0 to 2 dx is equivalent to the limit as x approaches to infinity, summation of 1 to n f of x sub I star delta x equals to the limit as x approaches to infinity, 14n squared plus 12n plus 4 all over 3n squared. As we can see that it has the same highest exponent, then all we have to do is get the horizontal asymptote. And the horizontal asymptote in this is 14 over 3. And this will be our final answer. Hope you guys learned something on how to solve definite integrals.